Hi guys, today we're gonna move on lesson 2, experimental probability. Before doing experimental probability, I just want to revise a bit on theoretical probability. For example, if you have a fair 6-face die and you roll that die 20 times, can you find for me the chance to get a 3? So in experimental probability, to find a probability of an event, you get the number of favorable outcomes divided by the total of outcomes. And our favorable outcome here is getting a 3. And the number of favorable outcomes of rolling a 3 is 1 times with the times 20 times that you roll that die divided by the total of outcomes, which is 6 faces, times with 20 times that you roll the dice, and it's equal 1 out of 6. You do the same thing, you will get the probability of getting a 1 equal probability of getting a 2, a 3, a 4, and a 6, which is equal 1 out of 6 for all of them. However, in the real life, when you roll a die 20 times, it's going to be different. For example, in this one, and that's how we call experimental probability. So, in experiment, I did an experiment with a same fair 6-face dice, and I rolled that dice 20 times and record the number of outcomes. You can see here, the frequency of getting a 1 is 3, which is different with the frequency of getting a 2, which is 1. A frequency of getting a 3 is 4, when the frequency of getting a 4 is 6. They are different. They can be, they're not the same, exactly the same each other, like theoretical probability. The first answer, how many trials were there? To find the total trials, you just add all the frequency up. So the total trials here equals 3 plus 1 plus 4 plus 6 plus 3 plus 3. These frequency, you add them up and it's equal 20. So there are 20 trials in total. Question B, how many trees? It means the face that has 3 dots were rolled or were up. Look at this table and look for the outcomes 3. Your favorable outcome here is 3. So there are 4 times that the trees were rolled up. So your answer is 4. C. What was the relative frequency for each number and written as decimal? In probability, experimental probability, to find the relative frequency of an outcome, or we call experimental probability, is equal to the frequency of the outcomes divided by the total number of the trials. So these two formulas are the same. To do this one, to answer this question, I reconstructed this table into this table. The first column is for me to write the outcomes, which are 1, 2, 3, 4, 5, 6 faces. And the second column is to write out the frequency. With this one, I just copy down exactly from this table to this table. And the final columns is for me to find the relative frequency, or we call experimental probability of an event. The last row of this column, I will calculate the total of frequency. So I add them all up, and this one is exactly the same with the total trials that we calculated in question A. Okay, so to find the relative frequency of rolling a 1, using this or this formula is equal to the frequency of getting a 1, which is 3, divided by the total number of trials, which is 20, and it's equal 0.15. Same thing, to find the probability the frequency of getting the relative frequency of getting a 2 is equal the frequency of getting a 2, which is 1 here, divided by the total trials, which is 20, so it's equal 0.05. You do the same thing with probability of getting a 3, a 4, a 5, and a 6. So how about here, 3? the relative frequency of getting a 3 is equal 4 divided by the total trials, which is 20, and is equal 0.2. This one. You do the same thing to find the relative frequency of getting a 5 and a 6. And there you go. So that's how you answer. That's how you find the relative frequency of an outcome or experimental probability of that outcome. Thank you for watching.